Howdy, my name is Bernie Flores.
Howdy, my name is Nick Olmos.
Howdy, my name is Daniel Merlizadeh.
My name is Guadalupe Rodriguez III.
My name is Giselle Ramos.
And we are covering induction machines. This is an assignment for Dr. Kate Davis's EASN 340 class at Texas A&M University, fall of 2019.
How it works. Alternating currents in the stator add up to produce a rotating magnetic field. The rotating magnetic field induces a current in the rotor windings. The induced current in the rotor windings produce a magnetic field. These two magnetic fields produce a torque on the rotor. The rotor speed will increase until the relative velocity is enough to balance the opposing torque from the load. The speed of the rotor is never equal to the speed of the stator, because if this happens, then there wouldn't be current in the rotor windings. Slip is the difference of the stator and rotor speed, and it is what makes induction machines work. Below are equations for slip and stator speed.
A squirrel cage rotor consists of a cylinder of steel laminations with aluminum or copper conductors embedded in its surface. In operation, the non-rotating stator winding is connected to an alternating current power source. The alternating current in the stator produces a rotating magnetic field. The rotor winding has current induced in it by the stator field, like a transformer, except that the current in the rotor is varying at the stator field rotation rate minus the physical rotation rate. The interaction of the magnetic fields of currents in the stator and rotor produce a torque on the rotor. By adjusting the shape of the bars in the rotor, the speed-torque characteristics of the motor can be changed to minimize starting current or to maximize the low-speed torque. A wound rotor motor is a type of induction motor where the rotor windings are connected through slip rings to external resistance. Adjusting the resistance allows control of the speed-torque characteristics of the motor. Wound rotor motors can be started with low inrush current by inserting high resistance into the rotor circuit. As the motor accelerates, the resistance can be decreased. Compared to a squirrel cage rotor, the rotor of the slip ring motor has more winding turns. The induced voltage is then higher and the current lower.
So now on to applications of the induction motors. The induction motors are mainly used as a motor rather than a generator. And three-phase motors are used in compressors, pumps, and wind turbines.
In the cases of use as a generator, the slip is negative. Examples of this are wind turbines and hydro turbines.
Induction operation for a motor and generator. For the motor and generator operation, the stator and rotor spin in the same direction. For a motor, as load on the motor increases, the rotor slows down. When the rotor slows down, the slip increases. If the rotor could move at synchronous speeds, there would be no relative motion, no current, and no force to keep the rotor going. Meanwhile, generator operation occurs when the slip is negative, which is caused by a faster rotor versus a stator.
We will now show you a simple problem involving induction motors. So first, we're going to use this formula seen below to find the no-load synchronous speed. And so we plug in the 60 Hertz frequency and the 4 poles that were given to us in the problem onto the P. That then gives us the 1800 RPMs. And we use this value for finding the rotor slip. We use this formula highlighted and managed to get this value. Finally, we use the slip and the frequency, we multiply them together, seen below, and get this value.